Ladies, gentlemen, no variations thereupon, I needed a place to store my face mask. So naturally, I built Hobbiton. Want to find out how? Follow me. So the first step, and most important step, as always, is to plan out your work. Now, electronics to me is fairly intuitive. I just am able to plan it out in my head, so I don't normally draw things out, but it's always helpful to have a schematic drawing beforehand, if for no other reason than it allows you to know exactly how much space you need inside your project in order to fit everything in. Because the last thing you want to do is build a elaborate and fancy design and then find out you've not got enough room in there for your power pack, and you know you've got to cut chunks of it out and mess it up in order to fit everything in. So before we do anything, we're going to draw out a schematic of the components we need, and I'm going to walk you through how exactly you're going to do that. I'm going to try and do it from a beginner's perspective, but like I said, this is very intuitive to me. If it's not intuitive to you and you get lost in it, it's perfectly fine. We all have our own different areas of expertise, our own talent. That being said, because it's something I find intuitive, I might go a little bit faster than you're comfortable with, and if that's the case, somebody who doesn't intuit electronics like I do is Adam Savage. See what I meant when I said it's perfectly fine if you don't intuit it? Adam Savage did his own guide on planning out electronics, and because he doesn't intuit it like I do, you might find it more helpful to follow his guide, but I'm going to try my best to do a beginner's guide here. And so with a quick sip of tea, let's begin. Now, not all circuits require LEDs, not all of them require motors or actuators or speakers or anything of that nature, and sometimes circuits don't even require wires, but all circuits require a power source. So the first thing is to put on the power source. So that's your power source up there, which is going to be a battery. The next part is to add in the switches, and to do a switch you have a 45-degree angle line with a circle, then another circle there, so that's the switch. You close that, you'll shut the switch. That's actually showing an open switch, and we want 4 of those, and then we want 4 LED bulbs. Now there are several ways to draw light bulbs. The way I like to do it is to actually draw a light bulb, so it looks like the Greek letter omega, and then put that in a circle. And the reason I like to do it this way around is that the bulb has a leg off each side, so I can connect the wires to each end. Now there are 2 basic ways to hook up a circuit. You can do them in parallel or in series. The simplest way is in series, but that has some significant pitfalls. If they're in a series, then you have it like Christmas tree lights, where you have power source coming in, bulb, 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 all the way along. And the thing with hooking them up that way is each bulb you add adds resistance to the circuit. So if you're having one consistent power source with particular voltage, if you keep adding resistance on, your bulbs will get dimmer and dimmer and dimmer and dimmer the more you add on, until they reach a point where not enough current can flow through and they just won't light up at all. And another thing that can go wrong with it is that, as anyone who had Christmas tree lights in the 90s will be able to tell you, so if one of the bulbs is taken out or blows or anything like that, then the whole system stops working, the electricity cannot flow. And in order to find out which one's blown, you'd have to take out each individual bulb and replace it to try and find the one that doesn't work. But there is another way of hooking them up, and that's in parallel, which is what we're going to do here. In parallel, each bulb in this example is going to be on its own separate circuit. For a circuit in parallel, what you'd have is a power source, a long wire coming out, and then junctions off of that wire, where you'd have your switches and your bulbs, so that each one is essentially on its own circuit. If one of them goes out, it doesn't blow the whole thing. And the other advantage is that you don't add resistance the more bulbs you add. In fact, there's complicated maths that goes on in there, and you can end up with less resistance than any of the bulbs. But you don't worry about that. We're not concerning ourselves with that right now. And more importantly, you'd be able to switch off any of the bulbs without destroying the entire circuit, which is something you wouldn't be able to do if they were hooked up in series. So to go. Then have one long wire along the bottom. I'm going to connect this wire up to the switches on the long end. So each one of these is a junction that separates this out onto its own circuit. And then we'll connect the bulb up via that end. So if we shut that switch, it'll complete the circuit. And the bulb comes back out up here. We'll do that to all of them. And then it connects in on a long wire here that goes back to the power cell. And that's the basic circuit. So let's get the components so you can see exactly what sort of size we're working with. So in terms of switches, we have 1, 2, 3, and 4 switches. And for LED bulbs, we have 1, 4. For the power cell, there's 1 there, but I'm going to plan on putting some extras in. But that is essentially going to represent. And then the wires, I'm not going to cut them to length now because it's not going to be the same length, but you can see the sort of space we need on the inside. So we'll have 1 window with this bulb behind, 1 window with that bulb, so we're going to have 4 windows for each bulb, and then the switches are going to stick out along the front. So that's the size of the circuit, and for reference, that's the size of the Pringles tube we're going to use. So as you can see, the power source will go inside the tube, and all of these will sit around. It's going to be fairly compact, so I can get away with having something slightly more elaborate on the outside. It's not going to interfere too much, but you can imagine if I were trying to fit all of this inside the Pringles tube with something this wide, I would struggle. So it helps to plan out things like that beforehand. Right, so first thing we've got is the Pringles can, and this is going to be the door to the Hobbit hole, and we want the open top end to be facing the back, so this is actually where the door is going to be. And the reason we want the open bit at the back is that I can use this then to seal up the power cells, and whenever the batteries need changing, I can open up the back, get into the batteries, change them and seal it up without doing anything to the front where the design is actually going to sit, which means I'm also going to need 2 holes either side so that the power cables can run through. So let's do a couple of cuts. The wires are only small, so anyway, to create the smaller windows next to the door, we're going to use this thin card of the Amazon package, and we're just going to use the lip that would seal down there. So we're going to cut out along there and then just roll that up tightly around a pen to create a very small circle that's going to act as the window. So let's get our knives and start slicing. do is cover this with a layer of what's essentially paper mache. It's PVA glue and water and newspaper. Now, in order to get it as smooth as possible without any creases, the ideal thing to do is use small strips of newspaper, because if you use a large area, you're more likely to have a crease as you go over a three-dimensional shape, because the newspaper is essentially two-dimensional and the two things don't tend to mesh very well. So ideally what you need to do is you take your PVA glue first, paint over the area that you're going to cover, and this is about a 50-50 mix of PVA glue and water, and then take thin strips of newspaper and layer them on so that we then get nice, smooth, even coverage. And the beauty of using PVA glue and water is when it dries, it will dry rock hard and slightly shiny, and that will be our base for painting. So it's the next morning and I've left this to dry overnight. So by now this has all gone hard and is ready for painting. But I had one of those nights where I couldn't sleep because I was constantly thinking about things, one of the things being this project, as well as the other projects. Because for a little peek behind the curtain, this is one of my few weeks off. So I'm trying to get as many projects done as I can this week, and some of them aren't going to be video worthy, they're just going to be painting walls and things. So I'm going to have to try and find efficiencies where I can in order to get as much done this week as possible. So, order of operations, this is where I'm going to find my efficiency. You see, up until this point I've just been doing one thing after another, working on a straight line. The logical place to start now would be to paint this up. So you'd have one solid base colour and then you'd build up more details over the top, wait for the one layer to dry, you paint the next layer, stick some bits on. However, for that approach to work you have to wait for each layer to dry before you can do the next piece. So what I'm going to do instead is I'm going to create all the little details first, paint them all at the same time, wait for them all to dry and then stick them on. It's not much, but it means I'm not waiting for one layer to dry, then applying the next one. All layers are drying at the same time. So what we're going to do is take some of the thin card and we're going to cut out some of the detailed shapes on there. Majority of it's going to be brickwork that goes around the doors and windows, but some of it is going to be little ledges, little wooden panelling, things of that nature. And I'm also going to do something with a fencing at the front which is going to hold the switches. All that's going to be painted up, and then when everything's dried, which will be this evening, then we'll stick it all together and then do the final touches. So let's get on with it. The eagle-eyed among you will notice that I've just painted over the windows, but fear not, the application of a damp cloth while it's still wet will take that straight off again. It's a good job I just did some testing with the breadboard, because I want this switch so that when it's in the up position as it is now, it will turn the LED on, and when it's down it will turn it off, because when it's up and it's on, I want something hanging off there, be it a key or a mask or something, and I want it down when there's nothing on there, so I've already gone out, just because that's just more logical to me because it's no longer a hook. I'd assumed that upright would be on when I'm touching the top and middle spike, but that's not the case. Upright is on when I'm touching the opposite two, the lower one and the middle one. So it means I'm going to have to mount this so that the unused spike, the top one, is the one glued on, so these hooks are going to hang down. I was going to have them up higher so they would form part of the fence, but I'm going to have to change our plans. So what I'm going to do is use a spot of hot glue on the top spike and just glue that onto the base of the Hobbit hole. As the keys are going to be quite weighty, I'm going to put another bigger blob on top just to try and give it that extra bit of reinforcement, because I was planning on having it the other way, which would have been stronger, but I have to adapt to the situation. Give that a moment to dry and then we'll move on to the electronics. But be smart about this bridge, you should solder the wires on first, because otherwise you're putting a soldering iron next to cardboard. That's a recipe for fire. Okay, so I didn't film any of that because I accidentally did my order of operations wrong and glued these on before I soldered, and as you can see I did start to singe some of the cardboard, so I had to really concentrate so I didn't film, just to make sure I didn't set anything on fire. So let me just run through exactly what we've got. So black is a positive wire that comes down to here, which is a junction of 3 wires, one that will go along its own circuit, the rest follow along down here, and we have others branching off for each switch. Then I've got them color coded for each LED, a red, a blue, a yellow and a green, and these are all yellow LEDs. They're just color coded in terms of the wire, so I know which one's going to which switch is going to which LED. Then the white one is the negative, which comes off the negative leg of all the LEDs, and they run into 2 separate tie-offs. So you've got 2 coming up this side, and we'll have another 2 coming up this side, and both of those along with the black are going to go into the Pringles can here, with the whites going in the side and the black going in the back, and that's going to be where the power source is going to sit, so that when I toggle these, the LED will come on. I'm going to use hot glue to seal all that in, but before I do that I'm going to use electrical tape just to seal off all of these junctions to make sure I don't get any shorts, and to lower the risk of fire, even though there's not really much because it's such low voltage. Nothing left to do now but add the finishing touches. I also added some little wire hook because the switches as they were not going to be strong enough to hold my keys. So wire hooks were hot glued onto the front. And there we have it, the electronic Hobbit hole to hold my keys and face mask.